Hi, welcome to Benchmark 2. Today's lesson in Benchmark 2 is on the behavior of light reflection. Before you start today's lesson, make sure you have a copy of the Red Sound and Light book, a copy of today's notes document, and a copy of the group lab activity. You may need to pause this video to do some of these activities as we progress through this together. Let's start with the warm-up. Get out your warm-ups and write today's date and answer the following question. Describe an event where you saw light waves reflected, and then describe a different event where you heard sound waves reflected. Pause the video if needed and complete the warm-up. Get a copy of the Red Book and open to page 112. Get a copy of today's notes and get ready to read quietly to yourself and take some notes. The notes page looks just like this. As you read page 112 silently to yourself, write down the 3 things that can happen to light rays when they strike an object. Then give an example of an object that is opaque, transparent, and translucent. Because we don't have enough materials, we probably won't do the demonstration on page 117, but if you have 2 small mirrors and you'd like to do this at home by yourself, feel free. So let's talk about this together as a class. Once you've completed the notes, let's talk together about what happens when light strikes a mirror. What happens when light strikes a piece of colored construction paper? And what happens when light strikes the window in our classroom? Pause the video and have a class discussion about this right now. Discuss what you should have written in today's notes. So the reflection activity on page 117 sort of looks like this. If you're able to do this at home with 2 mirrors, feel free, but you can take a look at what happens in the image of the nail polish bottle with 2 mirrors set up. What typically happens to the images that are reflected back to you in mirrors? How does the image change when 2 mirrors are set up? Do you see anything new? This is a good time to practice your oral communication skills, so feel free to pause the video to discuss this. For this slide, you're going to need to follow along on the notes page. There's a big box in the middle of the notes page for you to sketch this diagram of reflected rays. Make sure you have a copy of today's notes and draw everything you see on the slide in this diagram. So how do your eyes see images in a mirror? This is a really important diagram to understand. It's also the basis of our group lab. We're going to prove how reflection works in our group lab by trying to understand how light rays reflect off of mirrors. So everything around us is visible to our eyes because of reflected light rays. Some colors reflect certain wavelengths, some absorb. The best way to understand reflection is to use a mirror. So objects around us, even objects that aren't reflective like mirrors, are always reflecting light. When light reflects off a mirror, it sends reflected light rays into your eye, and your eye interprets these reflected rays as an imaginary image behind the mirror. So this diagram needs to be drawn into your notes. Let's say you're standing next to your friend looking in a mirror. We'll call that the object. The light rays actually reflect off of the object into the mirror and back into your eye. When you look into the mirror, you can see this image in the mirror. You can also see yourself too. But our eyes perceive this image as being behind the mirror. Why is that? It has to do with how our eyes interpret the reflected images across from us. So we have a rule of reflection which states that the angle in which rays hit a mirror is the same as the angle that's reflected back to our eyes. If you haven't learned about angles yet in math, we'll talk a little bit about it in this project. This is a measured angle here, and this is another measured angle here. And if we drew a line perpendicular to the mirror, these 2 measured angles would be the same. And our eye perceives the image as being directly behind the object in front of the mirror. So this can get a little bit complicated, and that's why we're doing a lab to help us understand reflected and incident rays. So what we're going to do is a lab where we trace reflected rays that are coming from objects into our eyes. Of all the labs we do in this project, this one is the longest and it ends up being the hardest, but don't be intimidated by that. We're going to pair up and more people will be in a group for this lab because of a lack of materials. We're going to start this on Friday and hopefully end it by Monday. And part of the lab will include collaboration and a specific job that you will follow. It will include oral communication points for sharing your lab results with another group, and knowledge and thinking points for correctly completing the lab. So if we go back to our notes, we can see that there's a portion of our notes that requires us to discuss the job descriptions. You'll be put into groups today. We're going to go over the lab together, which is actually a document that we'll look at today. And we're going to make sure that we understand all of the directions for the lab. So there's a lot going on, and it's really important that we have a job. Now, if you're in a group of 3, one person does each job. If you're in a group of 4, each day you can switch jobs so that one person is sitting out and another person picks up a job. Please, please, please be very clear on what your job will be before you begin the lab. The materials person is going to pick up all materials for the lab, set it up, return the materials at the end of the day, and contact the teacher if any help is needed. Materials for this lab include mirrors, clips to hold the mirrors up, graph paper, and a ruler. The directions and data job is very important. This is a long, detailed lab. There are a lot of pictures to help you understand what needs to be done. And this person needs to be very clear in the directions and explain to the materials person what they need to do with the mirrors, the clips, the graph paper, etc. These people need to be able to communicate clearly. The third job, the speak and do, will actually be the one to follow the directions, move the mirror, and position it. They'll verbally speak the results and what is seen. This person needs to tell the directions and data person what to write down. So the materials in the speak and do jobs are very similar. Basically, we have a setup person and another person to actually do the lab. The materials person will return everything at the end of the day. So take a minute, determine the jobs. Your teacher may assign each person a job, or you may get to pick, and write down what the jobs are in today's notes. Pause the video if you need to. Now, going off of what I just said and what's in the slides, take a moment to summarize each job. Make sure that you know what your job is, make sure you know who's doing each job, and make sure that you know how you're going to rotate jobs if you have 4 people in your group. Take your time, pause the video, and write down the job descriptions in these boxes. This is your notes for today and will go in your binder at the end of today's class. Pause the video if you need more time. The end of this screencast will be instructions on how to do the lab. So today's lab is meant to prove the law of reflection and to help you understand how light rays are reflected off a mirror into your eye and how an image, an imaginary image, is projected behind the mirror. Now, we all know the reflection in the mirror isn't actually an object behind the mirror, but our eye perceives it as that way. So this is a really important lab to help you understand the law of reflection. It also requires you to follow very detailed instructions. Hopefully the pictures in this lab help you. There are more pictures in the slides of students doing this lab in my classroom in past years that I think you might find helpful. So we'll start with a sheet of paper. This will be graph paper that's folded in half. The center line is drawn, and this will help you position your mirror. Make sure that you keep your graph paper handy and write your names and group number on it, as you'll need to get it for the second day of the lab. This works best if you use 2 clips and position your mirror on the center line. Make sure that you have your mirror exactly on the center line and that it's positioned in the same place each time you start the lab. Do not move the mirror or change position during this activity. That can cause the image to go in a different location and you'd have to start over again. We're going to use a plus sign on the paper as our image. Okay, we're not going to stick a pin in as the directions say elsewhere. We're just going to put a plus mark slightly to one side. You should be able to look in the mirror and see this mark on the other side of the mirror. Now, it's not actually over here, but if you look in the mirror, it appears to be. Make sure that you answer the checkpoint questions as they come and initial when the step of this lab is completed. Now, here comes the tricky part. What we're going to do is look at this plus sign or the image in the mirror and try to identify which direction the light rays are coming from that image into our eye. Make sure that you are down at eye level before you position your ruler. You're using your ruler as a pointing device to point to where you see the image in the mirror. You need to do this off to the opposite side. So if your plus sign's over here, you need to point your ruler off to the side. Make sure you view it at eye level and discuss why this is important. Now take another position, still off to the opposite side, and point the ruler at the mirror at the object again. Any other angle is fine. Just make sure that you're not on the other side of the plus mark. Again, don't move the mirror and make sure that you're at eye level. At this point in the lab, you should have 2 different lines drawn. They're pointing to the object that's imaginary in the back of the mirror that you drew, pointing the ruler at 2 different locations. What do these 2 drawn lines represent? If you're not sure, stop and think about this for a minute before moving on to the next part of the lab. It's really important to understand what these 2 drawn lines represent. Answer the questions and initial them when you're done. Okay, so now it's time to move the mirror. You're basically going to take the 2 lines that you drew with your ruler and extend them with dotted lines to the other side of the mirror. You're showing where the lines intersect. This is the other side of the mirror. Remember, this is what looks like is on the other side of the mirror. Stop and talk about what these 2 intersected lines represent. In other words, what's right here in the mirror. Talk about it and initial it when you're done. If you fold your paper in half, you should get 2 V-shaped lines like this. Now, sometimes you need to hold the graph paper up to the window to see these 2 lines. Sometimes it helps to go over these original lines with a Sharpie, but if you fold the paper right on this line, you should see this. Now, this should look sort of similar to this diagram. The only difference is we have 2 reflected rays, so 2 V shapes. You might need to hold this up to the window to see that. Now, this is the part where some people have to go back and try and draw their lines again because their 2 V shapes don't match up very well. All right, basically what you're attempting to get is this diagram here. This is the object being viewed, and these are 2 separate eye positions viewing the reflected image. I didn't type that, somebody else did, sorry about the typo. What you're going to do is use your protractor to prove the angle of reflection. Remember, the angle here should match the angle here. You're going to need to look up some terms online, these are not in your book, and define the angle of incidence and angle of reflection. You should be able to measure with your protractor this angle, as well as this angle and this angle. And if you've done your drawing correctly, these angles should match. These 2 match, and these 2 match. So you can document what your angles were down here, and then you can get ready to discuss what you've learned during this lab with another group. So you are going to have to fully understand this before you meet and discuss with another group. You can talk about all the things you did, your struggles, what you learned, what you came up with, places you think you made mistakes. The group that's listening to you will score you. And as a group, you will give yourself an oral communication grade for how well you discussed. Everyone in the group needs to speak. And then you're going to give yourself a team collaboration score. If you don't give me any reasoning, it's an automatic 0 for collaboration. So make sure you circle a score and give me a reason. This is a really tough lab, so don't get down on yourself. It takes a couple times to get it right. Please feel free to come back to my slideshow for some pictures that I think might help you with completing this lab. And you should be able to finish this lab by the end of our second day.